Howdy, fans of chemistry. It is day 65 in the classic Who Poisoned Mr. Duty lab. Normally be looking into Beer's Law some more, but the nice thing, this will give you some practice with some calculations related to Stoich and solutions. So, of course, you don't need that paper because you got the Google Docs, but take me out, I'm dissolving. I just want to fit in. And it's 1, 2, 3 ions out, I'm dissociating. I know, it's bad. It's even worse virtual. Cool. We're going to take a look at this problem right here. You're going to write it up into your ETD and give it a whirl. And as you do that, of course, you will hopefully pause me and try to figure it out on your own. And then we'll tackle it together. So pause me now, write down the question, take a swing at it, pun intended, and then we'll dive into it. Now we're diving into it. Yay, hopefully pause me. Now, key thing with this problem, you can see there's a lot of things going on. First thing you want to do, of course, notice there's a chemical equation, so you try to balance it. It's looking nice and balanced, right? We got some silver, some nitric acid, we're making some silver nitrate, some nitrous oxide, and some water. But key things in it, I asked myself what I got and what I need. I need the molarity of the nitric acid after the reaction, which makes this kind of a different type of question for us. You can also notice it's giving you lots of data, but at the end of this, I need the molarity, which means I need the moles per liter of this stuff called nitric acid. So that's what I'm shooting for, right? Then I can notice that I got 1.85 liters of the nitric at that concentration. I got this many grams of my solid silver, and it's telling me to assume that the volume is 1.85 at the end of this. So really, this is a question of you got two reactants, and anytime you have two reactants, that's a pretty good sign that you should think about who's going to run out first, limiting reactants, which typically what we've done is we've figured out, and both of them, we stoich them out and we figure out what's going on. But this question is actually more about what I have versus what I need, right? Which is a little different than got and need. Now, what I need, of course, is I need to completely react all of my silver. So that's the 25.3 grams of that silver. I need to figure out how many piles of nitric that I'm going to use up in doing that, right? So the way I can do that, of course, is the old handy thing called stoichiometry. I'm going to get rid of the grams of silver, turn it into moles of that stuff. So first thing I got to do is get rid of the grams of silver and turn that into moles of silver. When I do that, one pile that off your periodic table is 107.87 grams, right? Now I'm in a mole thing. Right? And once I'm in a mole thing, I can go from one substance to another using my mole to mole ratio. That's why we check the balance first. I'm going to get rid of the silver. I'm going to turn it into the nitric because I want to use that trick, right? If I look up here, I can see there are 3 of those for every 4 of those. It's a 4-to-3 ratio. When I punch that in, what that will give me is that'll give me exactly 0.313 moles of nitric. Now that is what I actually need because I want to completely react all of my silver. What I have is another story, and life's all about what you have versus what you need, right? Can't always get what you want. So if we look at this is about the nitric that I have. So the way that I tackle this is I want to go from and figure out how many moles of that I have. I know that I have a pretty good solution. I got a 0.525 mole per liter solution of nitric acid. Every 1 liter of it has that. So always getting the habit right in the big M is that. But I don't have a full liter. I got more than that. I got 1.85 liters of that nitric, which means that in my one sample, if the one makes you feel better, I can cancel out the liters and just figure out how many moles I have. When I punch that in, it tells me that I got, 3 siggy figgy. So that's actually 0.971 moles of the nitric. That's what I have. So I got this big old pile of nitric, right? That's in my entire jug. And then I take what I need, which was a much smaller pile of the nitric, and what I needed was the 0.313 moles of that nitric to react and get rid of all of that silver, change it anyways. So I take the difference, right? And then when I take that difference, I can take that and divide that by how many liters, and it tells you it's still 1.85 liters at the end of this. So if I take 0.971 minus 0.313, the little bit that I used it of, I'm going to take that chunk out of it. That's what's left over, but it's still in the 1.85 liters of solution. So that means in my 1.85 liters, I'm going to have a leftover chunk, the bigger chunk of the nitric, which is my moles per liter of it. And if you divide that out, it's 0.356 moles per liter. And you can see a crucial thing. I used up some of the nitric, so its concentration went down because I lost moles. If I lose moles, but I keep the same number of liters, the concentration should go down. So always ask yourself, of course, is the reaction balanced? What do I got? What do I need? And if you see two reactants, always ask yourself, which one's going to run out first? And you can see what I went to is I went to moles each time because you can compare the moles to each other. And that's what we're using up. And then I put it back into the solution, the liters of that stuff, because that pile is still inside of a beaker. Now it's just a smaller pile, right? Now, typically what we would do at this point was we'd take a real challenge. You would have done Beer's Law the day before, and we would have solved the criminal mystery of who poisoned Mr. Duty. You would have gotten some unknown solution. One of them was the one that poor Mr. Duty drank, and you'd use your laser and you'd shoot it and you'd figure out how concentrated, of course, the unknown that killed him was, and you'd be able to identify the schools. I won't give away who did it, but it's kind of a fun lab. Now, that, of course, is a part of our target today was to figure out and get some practice with more complex types of limiting reactant stoichiometry problems, but hopefully that is helpful to you.